Good afternoon to all. Today we have to discuss about maintenance and preservation of pure culture. Once a microorganism has been isolated and grown in a pure culture, it becomes necessary to maintain the viability and purity of microorganisms by keeping the pure cultures free from contamination. Normally in laboratories, the pure cultures are transferred periodically onto or into a fresh medium. That process is known as subculturing to allow continuous growth and viability of microorganisms. The transfer is always subject to aseptic conditions to avoid contaminations. Objectives of preservation: to maintain isolated pure cultures for extended periods in viable conditions, to avoid contamination, to restrict genetic change. Applications of preservation: academic use, research purpose, fermentation industry, biotechnological field. Once microorganism has been isolated and grown in a pure culture, it becomes necessary to maintain the viability and purity of the microorganisms by keeping the pure culture free from contamination. Normally in laboratories, the pure culture are transferred periodically onto or into a fresh medium. That process is known as subculturing to allow continuous growth and viability of microorganisms. The transfer is always subject to aseptic conditions to avoid contaminations. Since repeated subculturing is time consuming, it becomes difficult to maintain a large number of pure cultures successfully for a long time. In addition, there is a risk of genetic changes as well as contamination. Therefore, it is now being replaced by some modern methods that do not need frequent subculturing. These methods include refrigeration, paraffin method, cryopreservation, and lyophilization. Methods of preservation: periodic transfer into fresh media, storage in sterile soil, storage in low temperature, preservation by overlying cultures with mineral oil, freeze drying or lyophilization. First, periodic transfer to fresh media. Strains can be maintained by periodically preparing a fresh culture from the previous stock culture. The culture medium, the storage temperature, and the time interval at which the transfers are made vary with a species and must be ascertained and beforehand. The temperature and the type of medium chosen should support a slow rather than a rapid rate of growth so that the times interval between transfers can be as long as possible. Many of the more common heterotrophs remain viable for several weeks or months on a medium like nutrient agar. The transfer method has the disadvantage of failing to prevent changes in the characteristics of strain due to development of variants and mutants. Advantages: it is a simple method. Any special apparatus are not required. Easy to recover the culture. Disadvantages: the risk of contamination is more. It may be possible to change in genetic and biochemical characteristics. Next one is storage in sterile soil. It is mainly applied for the preservation of sporulating microorganisms, single spores within a cell. Example one: Fusarium, Penicillium, Alternaria, Rhizopus, Bacillus, Aspergillus, Penicillium, etc. proved successful store in sterile soil. Soil storage involves inoculation of 1 ml of spore suspension into soil, autoclaved twice, and incubated at room temperature 5 to 10 days. Initial growth period allows the fungus to use the available moisture and gradually to become dormant. The bottles are then stored at refrigerator. Viability: organism found around 70 to 80 years. Storage at low temperature. Culture medium can be successfully stored in refrigerated or cold rooms when the temperature is maintained at 4 degrees Celsius. Another, liquid nitrogen, can provide long-term preservation of culture. In this method, dense suspension of microorganism is prepared in a medium containing uh, a protective agent, glycerol or dimethyl sulfoxide, which prevent cell damage due to ice crystal formation. Suspension is sealed into small ampules or vials and then frozen at 150 degrees Celsius. At this temperature, the range of metabolic activity of microbes slow down greatly and slowly, and only small quantities of nutrients will be utilized. This method cannot be used for very long time because toxic products get accumulated which can kill the microbes. 10 to 30 years without changing the characteristics. Preservation by overlaying culture with a mineral oil or liquid paraffin storage. In this method, sterile liquid paraffin is poured over the slant culture microbes stored upright the room temperature, whereas the cultures can also maintain covering against slant by sterile mineral oil which is stored at room temperature perfectly, preferably at 0 to 5 degrees Celsius. It limits the oxygen access that reduces a microorganism metabolism and growth as well as to cell drying during preservation. The preservation period for bacteria from genera Acetobacter and Mycobacterium is from 7 to 10 years. For Bacillus it is 8 to 12 years. Advantages: simple, maintainedly used anaerobic microorganism cost effective method can preserve 10 to 15 years. Then next one is lyophilization or freeze drying. Freeze drying is a process where water and other solvents are removed from the frozen product via sublimation. Sublimation occurs when a frozen liquid goes to directly to a gaseous state without entering in a liquid phase. It is recommended using slow rates of cooling as this will result in formation of vertical ice crystal structures, thus allowing for more efficient water sublimation for frozen products. A small cotton plug vials containing frozen suspension of the microorganisms are placed in the flask which is attached to a condenser. The condenser is connected with a high vacuum pump and this system brings about desiccation of cultures. After desiccation of the cultures, as in a vials are removed, placed individually in a large tube covered with a asbestos packing under vacuum. Procedure: in this process, a dense cell suspension is placed in a small vials and frozen at minus 60 degrees Celsius to 70 degrees Celsius. The vials are immediately connected to a high vacuum line. The ice present in the frozen suspension evaporated under the vacuum. This results in dehydration of bacterial cells and their metabolic activities are stopped. As a result, the microbes go into dormant state and retain viability of years. The vials are then sealed off under vacuum and stored in the dark at 4 degrees Celsius in refrigerators. Advantages of lyophilization: only minimal storage space is required. Hundreds of lyophilized aqueous can be stored in a small area. Remainder sub-viable are more than 30 years. Frequent subculturing is not required. Maintained without contamination. Lyophilized strains remains genetically stable. Small vials can be sent conveniently through a mail into other microbiology laboratories when packed in special sealed mailing containers. This method is employed for the preservation of sera, toxins, enzymes and other biologicals. Conclusion: the pure culture maintenance technique is used for isolation preservation of culture from different samples. Those techniques are used for industrially important organisms, essentially for the check the quality of preserved microorganism stores. However, the preservation is essential as it reveals great importance in field of science. Preservation helps in research purposes, industry as well as in microbiological field.